So I want to start this discussion one more time. We talked about our general perception that if we are good in reading, chances are we are not doing very good in mathematics. Or otherwise, if you are very good in mathematics and you spend so much time in doing those mathematical formula that you don't have enough time to develop the skill for reading. So is this concept actually makes sense? That's what we are going to try to understand in our next problem. We did a lot of correlation and regression with this problem. I'm going to deterministically characterize this problem today with the new concepts of SST, SSE, SSR and correlation coefficient along with determination coefficient. So in the same problem, you have states, their mean SAT reading score and the mean SAT math score. And all we want to do today is find out deterministically is this presumption of if you are good in reading is going to characterize whether you are good in math or not is positively or negatively impacted. So let's try to understand that. So this is the table that we are familiar with. Given the table, it is asking us to find the residual and the squared residual. So just like the last problem. So all we need to do is go to our Excel spreadsheet. And we're going to populate the information there. So there are 5 data points, 497, 515, 518, 501, and 522. And the Y data points are 510, 515, 523, 514, 521. So once we have put them in, you remember the residues and the squared residues are these two columns. So we'll copy them and paste them in the problem. And I need to do a little bit of fitting of that information. So I think it looks good. And we need the SSE to be calculated. That's the next part. So let's see how much is the SSE. So this problem is telling us that the SSE is 25.6958. So I will say SSE is 25.6958. Let me check my work. 25.6958. Round it to 4 decimal places. Calculate the sample variance of Y. Then use it to find SST. So sample variance, I'm not going to do any calculation this time. So we're just going to use the spreadsheet. Sample variance S square for Y is going to be 28.3 units. I need SST. I know that I can multiply 28.3 by sample size minus 1 and get SST. But instead, I'm just going to use the spreadsheet. And the SST value is 113.2. Answers this question. Use SST and SSE to find SSR. Again, I know SSR is equal to SST minus SSE. Instead, just use the spreadsheet. So SSR is 87.5042. Then it is asking me to calculate and interpret the coefficient of determination R squared. Again, you know, R squared is SSR over SST, but just use the spreadsheet and round to 4 decimal places. So that one is 0.7730. 0.7730, because we need to interpret. I'm going to say this is 70, actually it is 7730. So change it to percentage, that's 77.3 percentages or 30 percentages. Interpretation, so what it says, the mean SAT reading score describes 77.3% of the reasons of variability in the mean SAT math score, the Y value, mean SAT math score. So what is our interpretation? 77% of the reasons why you are good in math is described by your well-preparedness in reading. So these two things are not correlated. They're very much correlated. If you're good in reading, then you're good in math. As good as you are in reading, as good as you will be in math. So they are positively correlated. So let's see what else we can talk about. It is asking us to use the R square and the B1 to find the correlation coefficient R. So coefficient. So the same thing, you know R square is 0.7730. Take the square roots on both sides, we'll get positive and negative values. So if I take the square root, I will get 0.7730. The square root of that is going to be 0.8792. Then from the spreadsheet, I will find out how much is B1, and B1 is equal to 0.4264, which is a positive constant, and that tells me my correlation coefficient must be positive as well, 0.8792. And this is what we talked about. We said that there is a positive relationship, and now we have kind of established that. Which state has the largest positive residual? Describe what this means. Positive residual. So let's go to our residual chart and find the largest positive number in there. So let's see in this Excel spreadsheet, and the largest positive residue is this one, the third state. So I need to know which one is the third state in this discussion. And the third state is Massachusetts. So we're going to say that Massachusetts has the largest positive residue. Has the largest positive residue. And again, what it does mean, it means the prediction error for the state is maximum. And remember, if the prediction error is positive, then we get to say, and the actual data is higher than the predicted data. So this is kind of twofold. It is telling you which state has the maximum error in prediction, and it also tells you whether you have underestimated or overestimated. Clearly this time you underestimated because the actual data is larger than the predicted data. Similar question, which state has the largest negative residue? And what does it mean? So largest negative residue will be this one, which is the second state. Let's see which state is that. The second state is Connecticut. So we're going to go ahead and say Connecticut has the largest negative residue. And this means the state has maximum error, not only that, maximum prediction error. This time your prediction error is negative, so you get to say, and the actual data is smaller than the prediction data. So this time we overestimated. because our estimation is bigger than the actual data, so you overestimated the mean SAT math score for Connecticut. There is no zero score for SAT reading test. Does the y-intercept make sense for this data set? Explain. So we'll say no, it does not. We answered this question already once. No, it does not make sense. And why it doesn't make sense? Well, because mean SAT reading score can not be zero. Use the regression results to either support or refute the claim. Suppose someone said that for every additional point increase in the mean SAT reading score, do not forget, this is your X, so you are changing 1 in X, and it is saying you could expect a 1 point increase in the mean SAT math score. So that's your 1. So 1 point increase in mean SAT reading score will imply 1 point increase in mean SAT math score. Is this true? No. Why it is not true? So first and foremost, I'm going to refute. And why I'm going to refute? Remember, B1 is that identification. So what was the value of B1? We used it once. B1 is equal to 0.4264. So that's the amount you are expecting. B1 is 0.4264, and I will just say, so 1 point increase in the X will cause 0.4264 point increase in Y. So the statement is false and I refute. Suppose someone claimed that there was no correlation at all between mean SAT reading score and mean SAT math score. Will you accept or refute? So far what I have shown you, it seems like there is some correlation. But remember, we did not do the deterministic test yet. What is the deterministic test? Not only you will need the correlation coefficient we found out to be 0.8792. Because it is already positive, it doesn't matter whether we take the absolute value of R or not. I'm still going to do it. So 0.8792, which is 0.8792. And I'm going to find the sample size. The sample size is 5. Then go to our G-check table and find the critical number for this sample size. Our correlation must be greater than the critical number. So let's go to the critical check table. Sample size 5 means the critical check value is 0.878. So let's use that. This is 0.878, and clearly 0.8792 is greater than 0.878. So there is correlation. I have deterministically proved that there is correlation. What does that mean? Means I'm going to refute again. This is not a right statement. Suppose someone claimed that one could predict the mean SAT math score to within 3 points using the mean SAT reading score. So the margin of error, someone is saying, is less than 3, within 3. So I will just say this way. Small s, as per this claim, is less than 3. Is it good or not? Well, what was small s for this problem? Why don't we go back to the spreadsheet and check it ourselves? Small s for this problem was equal to 2.9266 rounded to 4 decimal places. So small s is 2.9266, which is indeed less than 3. So this is good, and I support the statement. Suppose a newspaper said that the mean SAT reading score explained over half of the variability. So mean SAT reading score explained over half. So greater than 50% of the reasons of variability are explained by mean SAT reading score. Is it true or not? Well, how much we found out? In the interpretation of R square, we found it explains 77.3% of the regions of variability. So that's more than 50% for sure. So we'll say that, yeah, 77.3% is more than 50%. So we are good. So we support this statement made by the newspaper. What if the mean ACT math score for New York was much higher than 510? Describe what would happen to the slope and the y-intercept of the regression line and why. So I will skip this part why, because we are not going to go in the detail of regression analysis. But what I will show you, if I just go ahead and change New York score from 510 to much higher score, so for example 700, and see the change in the scatter plot. So see how the line has started falling down. What does this mean? That the slope has become a negative slope. It was a positive slope, it has become a negative slope. What else has changed? If you continue doing this line and let it cross the y-axis, then you will find that this line is going to cross the y-axis at a much higher point than it was crossing initially. So these are the two changes that we're going to describe in the last problem. So we'll say that the slope, remember from positive it became negative, right? So the slope will decrease. What else? The y-intercept is going up, so we'll say the y-intercept will increase. And that would answer my question. As I said, we're going to skip the y part for this problem because it will require much more mathematical preparedness, which we are not expected to have for this class. So that answers this question, and this is going to conclude chapter 4. Next time, in our next video, we will start talking about mathematical probability and counting.